Hi guys, welcome back to the training series of machine learning using Python. So today I'm going to talk about random forest. So it is another machine learning algorithm and it is used for supervised machine learning. Means what is to be predicted is already there in the training data set, and we can use this algorithm for two purposes: to build a classification model and also to build a regression model. And it is based on the technique called as ensemble learning. The basic meaning of ensemble is joining, combining. So ensemble learning is the type of learning where you can join different types of algorithms, or you can use same algorithm multiple times in order to develop a powerful machine learning model. So far in the previous sessions, so we took decision trees, logistic regression, linear regression. So there we developed a single model. So the performance of the model depends on only single algorithm, and that is only once. But most of the time we would like to have a powerful model. So for that you can use the same algorithm multiple times to improve the accuracy of the algorithm or model, or you can use different types of algorithm. So finally getting a very efficient machine learning model. So that is the concept of random forest. I repeat again. So ensemble means joining different types of algorithms, or you can use same algorithms multiple times. Here a random forest uses the same algorithms multiple times and it tried to develop a powerful model. So here we are going to generate a set of trees, so that's why the name is random forest. So what is the meaning of forest? Forest is nothing but set of trees, right? A forest is nothing but set of trees. So trees are constructed randomly, so that's why the name is random forest. So random forest create set of decision trees on randomly selected data samples, and then the prediction from each tree is considered, and then voting is done, right? The prediction from each tree is considered and then voting is done. So whichever no tree gives the better results, so that is the final selection. So random forest has variety of applications, like you can use random forest in building recommendation systems or in image classifications and feature selection. Random forest can also be used in classifying the um, loyal loan applicants and identifying the fraudulent activities and making the prediction of diseases. So there are many applications. It is one of the very powerful algorithm which gives you a better accuracy. So one of the simple example we would like to take is, suppose you want to go on a trip but you are unsure where to go. So in that case the best option is you can just search it out in Google and find out a set of places. Let's say you found 5 places, even there is an ambiguity, right? So out of 5, what is the right place to go with? In that case you can perform voting. So you can assign that task to your friends and you can ask them, suggest me the best place out of these 5. Then your friends can recommend you the particular place. Again, let's say there are 3 top suggestions. Again there is an ambiguity. Then again voting is done. So finally the place whichever no gets a higher count or higher vote value, so that is the final decision. So like this random forest works. The tree whichever gives the better results, so that is considered. So how does the random forest algorithm works? So these are the steps. These are the algorithmic steps. First, random samples are selected. What do you mean by sample? Sample means rows from the training data set. And then construct a decision tree for each sample. So for each sample, you're going to construct a decision tree and then get the prediction from that tree and then perform voting for each predicted results. And then finally, you have to select the prediction result with most votes. The tree which has resulted with most votes value is the final tree which is used for prediction. So these are the advantages of random forest. So random forest is considered as one of the highly accurate algorithm. so which gives you the better accuracy, and it doesn't suffer from the overfitting problem. So decision trees suffers the overfitting problem, but random forest not, because all the trees are used for the prediction, then finally voting is done. And this algorithm is used for both classification and also regression problems. And random forest can handle the missing values automatically. Means if there are any missing values, that is handled by the algorithm by itself. So now the question is, how does it handle? So there are two methods. You can use the median values to replace the continuous variable, or computing the proximity weighted average of the missing values. So in these two ways it handles the missing values. And one of the striking feature of random forest is it no it also evaluates the features automatically. So it's very important whenever you build a model. So what are the features to be selected? So those features are put into X, and then Y means your target variable. So feature evaluation is very important, but in the case of random forest, it automatically evaluates the features, and also we can have the list of important attributes that I'll show you. And then what are drawbacks? Drawbacks are, so random forest is considered as one of the slow model building algorithm, because here you are not generating a single decision tree. Here you build hundreds and thousands of trees, right? On all these hundreds and thousands of trees are used for a prediction. So whenever it makes a prediction, all the trees in the forest have to be used, and then voting is done, right? So this whole process is time consuming. It is a highly accurate, but the drawback is it takes time, and the model interpretation is a little bit difficult when you compare with decision trees. And decision trees now is the one of the best algorithms in terms of interpretation. Means once you have the classification trees and classification rules, by following these rules you can make a decision. So interpretation is not good over here. Feature importance is automatically done. I'll show you. And this is the one of the interview question. What is the difference between random forest and a decision tree? So random forest consists of set of trees, whereas in decision tree you're going to have single tree. And decision tree may suffer the problem of overfitting, but random forest not. And decision trees are computationally faster because only single tree is built, whereas in random forest you are developing multiple trees. So that's why random forest is slower. In terms of interpretation, decision trees are good, but not random forest. So this is a comparison between random forest and decision trees. Now let us see how to build a random forest model by using scikit-learn library. So we are using predefined data sets. So machine learning this scikit-learn library already comes with some predefined data set. So iris is one of the data set. I have already introduced you what is this iris in my previous session when we discussed about decision trees. So, but that time we have used the data set from UCI open repository, but here we'd like to use the built-in data set coming from scikit-learn. So at first from scikit-learn importing datasets, and then datasets dot load iris. Load iris is the function which will load the data, and that data is available into the variable iris. And it already coming with target names and feature names. So target names means as you know, the iris dataset has the target variable spaces, and which is having three unique values: setosa, versicolor, and vozunica. It is going to print that when you run this statement, print iris dot target names. And we would like to also print the feature names. Feature means other than the target variable, like sepal length, sepal width, petal length, petal width. So there are 4 features. So this data set totally has 5 features, 5 columns. So they are printed. So these are the values for target variable, and these are the features: sepal length in centimeter, sepal width, petal length, petal width. So based on these four values, you are going to classify a figure is either setosa type, versicolor, or virginica. Then just to have a sample look of data, so we are printing first 5 rows, iris dot data of 0 to 5, first 5 rows, and then what are their values, target values. So these are the first 5 rows. So for this, the target value is 0 0 0 0 0. As you know, this data set is equally distributed, so it has totally 150 rows, and 50 samples belongs to the class setosa, which we are labeling it as 0. So 0 means setosa, 1 means versicolor, 2 means virginica. So first 50 belongs to setosa, next 50 belongs to versicolor, and remaining 50 belongs to the class of virginica. So from this, I'm creating a data frame here. So importing pandas as PD, and then PD dot data frame. So we are giving the column name sepal length, which is equals to the first column, iris dot data of 0. Second column is sepal width, third column is petal length, and fourth column is petal width. And then this is the target variable spaces. So data frame is created, and then head means by default it will display first 5 rows. So these are the first 5 rows, and this is the target variable. So what are we going to do next is, you can put we just put this we put this into x. So this is our x, and this is our target variable y. So we have to do data separation, and then again we would like to split this data into training and testing. Okay, training and testing. This is x train, this is y train, this part is x test, and this part is y test, right? So we'll always build a model by using training data. So the model learns from x train and y train. Then we can evaluate our model by using x state. Then it will make the prediction, and then we check the predicted value with the y test. So I'm checking the shape of the data. Shape means number of rows and number of columns. So you can see 150 rows and 5 columns. And so this is the clean data. We don't need to do any data pre-processing. I will introduce the things, how do you process or how do you clean data when it has problems in my future sessions. So train test split imported from scikit-learn.model selection. As I mentioned, so x is having the first 4 columns, and y is the target variable spaces, and splitting x and y into 80% training and test is 0.2, means 20%. So data is splitted. Now I'm importing the algorithm. So this is a classification problem. So there are only 0 1 2 three values, not continuous type. So importing random forest classifier from the module scikit-learn.ensemble. Then I'm building 100 decision trees here. So this is the parameter to the class. So CLF is the model name, which means classifier is equals to random forest classifier, and it is taking the parameter n underscore estimators, means number of estimators, means how many decision trees are going to be part of forest. So 100 decision tree, and this is configurable value. So you can make it 1000, you can make it 5000, you can make it 50 also, you can make it 10 also. So it is the you can set the value for this. So machine learning means trial and error approach only. You take some values, if the model is good, then you can stick those values, or else you need to change. Then fitting data, x train dot values and y train dot values to the model, means the model learn from here. And then making the prediction for x test, we have 20% x test. Then making the predictions, the results are available into the y predict, then displaying what are there in y predict. So you can see these are the prediction for 20% of 150. You can check the shapes. 20% means 30 samples. 20% of 150 is 30. So there are 30 samples in the prediction. So once the model is built, you can evaluate. So I'm importing accuracy score from scikit-learn.metrics, and accuracy score is the predefined method which is taking two parameters here. Y test means actual value, Y predict means what the model has predicted. Then if there is a difference between that, we can say error, otherwise no error. So you can see the accuracy is 93%. Okay, the accuracy is 93%. It means model is accurate of 93, so it can make mistake of 7%. So we have made the prediction for 20%. Now if you take some sample, unknown sample, like this is sepal length, sepal width, petal length, petal width. If you give this, then what the model will make the prediction. So it has predicted 2. 2 means Vozinica. 0 for setosa, 1 for versicolor, and 2 for Vozinica. So 2 means for this the model has predicted the class type or flower type as Vozinica. And as I mentioned before, so the random forest algorithm automatically gives the features importance. So if you want to take help on this, you can take like this. So you can go through the different parameters and what is the meaning of them. Then here I am creating a pandas series here, PD series. CLF means our model name dot. This is predefined constant. Feature underscore importance underscore. So once the model is built, it will evaluate the features and those values are available into this constant. Then index is equals to the feature names, and we are sorting the values in descending order here. Ascending false means descending, then displaying the values of this. You can see petal width has the higher feature importance, 0.52. Next is 0.36, which is petal length. Next is sepal length, 0.08, and the least important feature is sepal width, 0.02. So after building this, after having this, I just want to display these things. So the feature importance with the help of graph. Which graph is that? Bar plot. So importing matplotlib and then importing cborn. I think we are not using cborn. If it is used, you can use it. Otherwise, you can ignore it. So cborn, yeah, yes, we are using it. So cborn dot bar plot of on x I'm showing feature importance, and y on y-axis showing the index, and this is the title of the x-axis, this is the title of the y-axis, and this is the title of the figure. Then plt dot show, then the graph is shown. As we have seen numerically over here, petal width has higher importance than this, so sepal width has less importance, 0.02. So this is a horizontal bar chart. Next, I would like to build a model with only top 3 features. So x is equals to data of, these are the top 3: petal length, petal width, sepal length. So we have excluded sepal width. Then y is space is everything is same here, 20%. We set random state here. Now let's build a model, right? Let's build a model. The prediction is done, and they are available in y predict. Okay, they are available in y predict. So let's make it rename it y predict 1. Then so evaluating the model with these metrics: confusion matrix, classification report, accuracy scores. I have already explained you what is the meaning of this classification report, confusion matrix, and accuracy score in my lecture session, decision trees. So if you have any doubts, or if these things are not clear, you can refer that video. I'm displaying the confusion matrix, classification report, and accuracy. So this is the confusion matrix. You see in 0 class 10 samples are classified and there are no misclassifications. In 1 class 9 samples are classified and no misclassifications. And in class 2, so 11 samples are classified, no misclassifications. As there are no misclassification, the accuracy is 1.00, means 100%. Okay, even we have built a model with only top 3 features, the accuracy is 100%. So this is about building a random forest model. You can adapt the same process when you have another kind of data set. For more information, you can refer the manual of scikit-learn on the metrics and how the random forest algorithm works. So you can go through the API of scikit-learn. So guys, that's it from me today. So if you have any questions, you can also reach out to me, and do subscribe our channel so that you can get the updated videos as notifications.